190 million years ago, a dinosaur with a bizarre bony crest on its skull was hunting through a forest of ferns and conifers. Not in South America, not in Africa, in Antarctica. That dinosaur was Cryolophosaurus, the first meat-eating dinosaur ever found on the continent and one of the largest land predators of the early Jurassic. It was about 20 feet long, weighed over 1,000 pounds, and had a distinctive pompadour-shaped ridge running across the top of its head. Its name means frozen crested lizard, not because the crest was frozen, but because it was found locked in Antarctic rock thousands of feet above sea level. And Cryolophosaurus wasn't alone. Paleontologists have since found the bones of sauropodomorphs like Glacialisaurus, plant-eaters that stretched over 20 feet long, along with pterosaurs, marine reptiles, and mammal-like creatures called tritylodonts. Today, the continent is buried under ice that averages over a mile thick, reaching nearly 3 miles at its deepest point. But rewind the clock far enough, and Antarctica looked more like modern New Zealand than the frozen wasteland we know. So what made this place capable of supporting such large creatures? To understand that, you have to understand what Antarctica used to be. 200 million years ago, Antarctica wasn't sitting alone at the bottom of the world. It was locked into Gondwana, a supercontinent that connected it to South America, Africa, India, and Australia. Rivers carved through dense forests. Temperatures were warm enough for broad-leafed trees and thick undergrowth. The region where Cryolophosaurus lived sat roughly 600 miles further north than Antarctica sits today, and the climate resembled the open woodlands you'd find on New Zealand's North Island. This wasn't some frozen desert with a few tough plants clinging to life. This was a thriving ecosystem with enough vegetation to feed large herbivores and enough herbivores to sustain large predators. But a warm climate alone doesn't fully explain the size of these animals. One factor that may have played a role is oxygen. Some studies suggest that atmospheric oxygen levels during parts of the Mesozoic era were higher than today's 21%, potentially reaching 30% during the late Cretaceous. Higher oxygen levels would have allowed animals to sustain larger, more energy-demanding bodies. However, this is still debated among scientists. Other studies using fossilized plant resins have found that oxygen may have actually been lower during parts of the dinosaur age. The science isn't settled, but the possibility of richer air remains one piece of the puzzle. What is more certain is the food supply. Antarctica's position near the South Pole meant it experienced extreme seasonal light cycles. During the southern summer, the sun barely set for months. Near continuous sunlight drove explosive plant growth. Ferns, seed ferns, and ancient conifers blanketed the landscape. For herbivores, this was a seasonal feast that produced enormous quantities of food in a short window. Animals that could take advantage of the long summer and store energy for the dark winter months had a clear survival advantage. Larger bodies retain heat more efficiently, carry more fat reserves, and can go longer between meals. Over millions of years, these pressures may have favored bigger body sizes in some Antarctic species. Then there's the question of isolation. As Gondwana slowly broke apart over tens of millions of years, Antarctica drifted further south and became increasingly cut off from other land masses. Species that were stranded on the continent faced a different set of evolutionary pressures. With fewer new predators or competitors arriving from neighboring continents, existing species had more room and more resources. In some cases, reduced competition and abundant food can push species toward larger body sizes over generations. The marine environment around Antarctica tells a parallel story. Plesiosaurs and mosasaurs patrolled the seas surrounding the continent during the Cretaceous period. The cold, nutrient-rich waters supported massive blooms of plankton, which fed fish, which fed increasingly large marine predators. The food chain was deep and productive. Antarctica served as a land bridge too. A recent study found that sauropod dinosaurs likely traveled between South America and Australia through Antarctica during the mid-Cretaceous, roughly 95 million years ago. The continent wasn't just home to large animals, it was a highway connecting populations across the southern hemisphere. So what ended all of this? The timing is still debated, but sometime between 50 and 30 million years ago, Antarctica separated from South America and the Drake Passage opened. The Antarctic circumpolar current formed, circling the continent and blocking warm water from reaching its shores. Around 34 million years ago, global temperatures dropped sharply. The forests died, ice advanced across the continent. Within a few million years, a sheet of ice swallowed everything. The large animals, the forests, the rivers, all of it locked beneath a frozen layer that persists to this day. But here's what makes this story worth telling. Those fossils are still down there. Every few years, a research team chips something extraordinary out of Antarctic rock. A new species, a new piece of the puzzle. Another reminder that the coldest place on Earth was once one of the most alive. If you found this fascinating, hit subscribe. I cover lost worlds and prehistoric mysteries every week. And if you want to know what would happen if Antarctica's ice actually melted today, that video is coming soon.